And we're live.
We're live.
Okay. All right. Just fulfilling my promise of being today's LLM. Hi, everybody. Welcome back to In the Arena, where we sit down with builders and thinkers shaping the frontier of AI and crypto. I'm Andrew Hill, CEO of Recall Labs, joined by CTO Carson Farmer. And today we're catching up with our longtime friend and collaborator, Juan Benet, and founder of Recall Labs and Filecoin. So I'm often so nervous to get on these kinds of chats and calls, but I have to tell you, I wasn't nervous at all for today's call because we've been working with Juan for years, and we've been talking about decentralized data and AI and crypto and philosophy and nerdy things forever. So I'm sure this is just going to be more of a jam than an interview. And we're going to just kind of dive in wherever it takes us. Let me kick it off. Quick question. Simulation or no simulation? What are we living in?
Oh,
That's
wow,
one.
we're getting starting there.
Right there.
Okay.
We'll work backwards.
Boston points out that it's very likely, just the likelihood of being sampled into kind of like the root universe is very low. My take on it is closer to the Tegmark multiverse. I'll explain it like super briefly. Max Tegmark is a physicist who came up with an additional classification. He came up with a classification of the multiverse because there's many different things that physicists mean when they say the word multiverse. And he introduced a fourth type called the mathematical multiverse, which the whole explanation is like a whole mind trip. And it's like, we could probably do like a 2-hour discussion on it because every time I talk about it with people, it's just kind of like this. I felt it that way. Other people feel it that way. It's like this mind expanding thing. So I'll just kind of tease the idea, which is just that our physical environment can be represented in a computer, and therefore it is actually embedded in math. All mathematical objects exist, and when you say like a triangle exists, it exists in mathematical reality, which is usually conceived to be separate from physical reality. But if Tegmark is right and the Tegmark multiverse is correct, then that means that our entire physical environment is embedded within a massive mathematical object, and that all other possible mathematical objects also exist, which means that like it's not just like the quantum mechanics multiverse where like you get tons of variations of almost exactly the same thing. This is just a much larger space, and if all of those exist, wow, it's like a totally different possibility space. And maybe the coolest idea that drops out of this is that you could do a thing called a causal trade across these, where like you could actually conceivably communicate across these. But I won't go super in depth into that because that's yet another like 2-hour conversation.
Okay.
Yeah.
We'll circle back down. We'll circle back around to this stuff. I'll ask another question I had in my mind. I'm really curious where you are on this. Give me on a 0 to 10 scale. How much code were you producing in 2016, 2022, and 2025?
Oof.
Personally,
this is like just very sad. I'll say that in 2013, 2014, I was probably
okay. Pick that date. Yep, good.
I was probably shipping code. Yeah, I just say I gotta hit my watermark. I was probably like working on code, somewhere between 8 to 13-hour days, like primarily programming, and it was awesome. And you can go back to my GitHub and look at that. All the commits. And so it was just a very large volume. That started dropping steadily up until like 2017, after which like it just started dropping dramatically faster. And probably it is every so often I would like break down and have to like go and build something for like a week or two. And I've started to mess around with stuff now with LLMs, which is great because it's like finally I'm able to like prototype a range of things that I wanted to do and whatnot. But I'm not yet as productive as I want to be. So I'm not yet on the upswing. I look forward to in a few years being back to where I used to be.
Yeah, I mean, productivity is just a totally different. I mean, the 18 to 13 hours that you're doing then, if you're doing that now, you would be just producing so many coded things. But the code you're creating, even just dabbling now, might line by line might be dominating 2013. No,
I don't know. I don't think so. Not yet.
Okay.
Well, there's a nuance
yeah.
to your question too, Andrew, which is, and I can't remember. It was only 10 seconds ago, but I can't remember the exact wording you used. But if it was code you're producing versus code you're writing, those are two different questions too.
I took the question literally. Code I was writing.
Producing.
Yeah, if we're talking about code I'm producing, with like through being able to hire other people and exchange, shells and currencies for code, then oh man, I don't know. It's a great question. Probably at this point, I've helped organize probably like a few thousand people's worth of code per year.
Yeah, that's a great way of looking at it. It's a lot of they all since May of last year, or no, May of this year, have probably all quadrupled their output.
If they're doing their, if they're paying attention.
Yeah.
Which I'm sure they all are. I mean, I think I have a similar trajectory. I was doing a lot more and then a lot less, and now I'm producing a lot more code again. I think that is probably a trajectory a lot of people are experiencing right now. Yep. Especially when you can bootstrap a project by saying, please bootstrap me this project, and then I'll take on it,
Yeah, I read a lot of code that gets thrown away just to validate, to think through an idea. But I definitely don't assign a maintainer to that stuff,
That ended up being my job afterwards. So I appreciate that.
What's the coolest, most complicated thing you've seen like a group of LLMs make for you?
So one thing I did about a month ago, I have I've been, like a lot of people, kind of experimenting with what are the right, I call them the rails and cushions for the coding agents. Like, how do you kind of set it all up? What are all the context, the rules for like a coding language? So for like TypeScript, like what are all your lint type, test requirements, like pre-commit hooks, commit patterns, all that stuff. What does it all look like to make this work right? And then who are the personas that you want to get working together to minimize the amount of verification that I have to do in order to get more steps down the path? And so I used, that Python library SnakeMake. So SnakeMake, for those of you that don't, it just lets you kind of build really cool little Python pipelines. But so I actually built an LLM pipeline that just kind of played these iterative loops of different personas, where a Claude was like the developer, and it had a really limited scope of what it could do. And then you kind of step out and there was a QA tester, and then step out and there are other folks. And so what it would do is at the beginning of the pipeline, you could prompt the MVP you wanted, and it would go to an agent that was responsible for speccing it out. And then I wouldn't have to verify that. It would actually be verified by a senior engineer to determine if the spec was buildable, and then do a loop. And then it would go into a planner who would write a bunch of tickets, and then it would execute each ticket within a loop until it was complete. And I've only actually run a couple things with it. It was more like seeing if I could prompt that thing. That thing I should actually just release, because I think it's pretty lit. But I think a lot of people that like want to build that tool are building it better than I am, and are going to maintain it. So I just never felt the urge to put it out, but it was pretty cool. And like so many things in the basic thing, the basic product there that I learned in the prompting flow itself. But already with like the release of like the skill plugins for Claude Code, it's already too out of date. Like I need to go.
Yeah. Those teams
do another.
So fast. Things are moving fast.
Yeah. How about you guys? Anything?
I made a simple RTS once. Like it just one-shotted an entire RTS for me to play. Like I just kind of wanted to see how well it could do. I gave it a little bit of flavor text of what to make, and made a playable game. It has some bugs that I spent a bunch of time fixing, but it was like pretty amazing how quickly like the whole thing could work. And could spawn units. You could like select multiple units at a time. You could like attack the other bases or whatever. You could like mine resources. It was like surprisingly good.
Games for one. That's pretty cool. Yeah. I think the most complicated thing I've done so far is I scoped, spec'd, and implemented. This is kind of nerdy, implemented a registry for A2A protocol. And we won't use that, but it helped me figure out how one might approach that. And it would work, and you could register with like cryptography. You could prove that you owned a particular domain and like all the things that you would need. And yeah, I didn't write a single line of that code.
I have one that we never released, Carson. I showed you this a few weeks ago. It's one of those demos on the cutting room floor, but it was an API for eval judging that would just always run it through kind of like be like a decision framework, and then have actually a cohort of judges for the eval. And then it would have on the back end another kind of system that was judging the judgers, so that it would build up intelligence on the judging ability through consensus and things. And then so that eventually you could start writing, or you basically write an eval request for different kinds of evals, and it would go to the API, and it would actually just pick the perfect judge based on what was actually being evaluated, the cheapest, sort of fastest, whatever. I thought, that's really cool. We'll actually use that in a couple of our internal tools. I have a CLI for it. I was demoing it to Carson. It just kind of worked. It was really cool, but maybe I should put that one out too.
You mentioned something kind of interesting there, just there. You mentioned the word consensus. I keep thinking there's an interesting experiment to be done, probably the world's most expensive consensus like framework or algorithm, but to try and get like teams of AI to debate and come to consensus on different topics and things like that. One of our, I don't know, you guys both know Chad from Blue Yard. He did an experiment like this where he would he'd pick a topic for discussion and get two LLMs to like debate either side of the topic, and then have a judge LLM kind of like decide on what the consensus outcome was of that debate was. And I thought that was a really interesting idea of like sort of, consensus is exhausting for humans, but actually for AI, you could probably actually code in some consensus building.
It reminds me of a hack that a friend of mine made in a research retreat that we had a few months ago. So we had, he made a thing called Simocracy, which is you create your own sim by answering a whole bunch of questions about your preferences and what you value and whatnot. And so there's usually a specific set of things that you're going to be kind of discussing. And then you run this larger simulation with a whole bunch of other people that are all together trying to decide some policy in policy space. And your sim goes and argues with everybody to like arrive at better and better decisions about, and it kind of represents your interests. And then you kind of figure out some policy. And yeah, it's like a really cool hack, and it like worked surprisingly well. And you could do it for like high level stuff like decision making on a product review, to like very hard things like, running this, you have a limited amount of money to fund, a set of possible projects, which ones do you fund and why? And or harder stuff like you have this concrete thing that you might allow or ban in a society type in a group setting, and figure out like the policy space of how that might impact you based on your values, even if you've never encountered that potential policy before.
Oh, that's pretty neat. Yeah, it's sort of it almost makes me think of that futocracy.
Futarchy.
Futarchy,
where you've got sort of like AI driving and humans getting involved. Okay. That's pretty cool.
Okay, we gotta. I can't believe we're almost done.
Yeah, we probably got to give the people time.
I gotta ask a question. Yeah. We're talking a lot about AI. We all work on blockchain. Where do they meet? how do they work together? What does AI get from blockchain? What does blockchain get from AI in your view? Is there a marriage here? Are they neighbors? Are they roommates? Are they, I don't know the analogy I'm looking for.
Analogy is going too far.
Yeah.
So they meet in a bunch of places. So one, we've already seen blockchains being able to be used to amass networks to train and run the system. So like there's like a very straightforward way of using deep networks to like boot up tons of AI systems. Then there is ways of using blockchains to verify at the end of the day, blockchains are entirely about verifiability. And so you can use that verifiability to think about what models you're running and what are the inputs that you're giving, and do those satisfy a certain set of policies, and can you then write some cryptographic proofs about the outputs and so on, so you can end up with like a dramatically better, much more secure and safeguarded system if you use cryptography with ML systems, AI systems. But the stuff that I'm most excited about, that I think is very near term, or I don't know, what I'm most excited about is like the long-term future. But near term, something that I'm very excited about is I think we're about to see AI systems build digital corporations online. And we've seen a few examples of this in the past. So this means, there was like, I think, was it Truth Terminal or that like kind of ran wild and tried to like raise money and kind of like run itself and whatnot. So there's versions of that, and like there's probably even more recent versions of doing that kind of thing. But there's something qualitatively missing still around being able to have an autonomous agent with some amount of resources and the ability to like enter into contracts with other parties, and that looks and feels a lot like a corporation. And so you can have digital corporations built on top of blockchains that are able to organize either single LLMs or many LLMs in one corporation, coordinating around some broad goal. And so I think we're likely close to seeing, just digital companies built by AI systems, like doing all kinds of knowledge work for now. Later on, once we get robotics good enough, which it's not too far away, probably like 2 to 5 years for a bunch of the kind of current robots to be like fairly usable, then those digital corporations can start operating in the real world, like in the physical world.
I think we're really close to that. There, you made me think of something. I'm going to say it half because I think it's interesting and true, and half because I'm going to make Carson smile. There's this thing. No, there's this thing. It's kind of like a little like it's kind of like this little fractal of how inside how things organized. That this property that I haven't seen really actually executed well with AI in the brain. I think of it a little bit like panpsychism. There it is. Like when you think about the brain, depending on like what behavior you're trying to execute, you kind of have different voices, and the right voice will dominate and kind of take over in that moment. So are you being competitive? Are you being collaborative? Are you being protective? Executing something important, whatever. You kind of have these different consciousnesses, and a different voice takes over at the right time. You see that same thing happen in human organizations, right? You don't say there is the supreme leader who makes all decisions. Decision making actually sort of more fluidly. Everybody just kind of agrees that this person should make this decision, or always has a good point of view in these moments, and kind of looks to them to make a decision. And that kind of natural trust and coordination, I haven't seen really work very well with LLMs. Like even that pipeline that I mentioned, like you have to be very like specific. You're going to hand it off to who, and you can see that the agent builders are starting to try to figure that out, but I haven't seen it work well. But I feel like to get a corporation right, you'd need a lot of that sort of fluid, like stepping up to be the leader to go execute the contract. Well, I'm going to get it. I'm going to review it legally, make sure it's good, make sure it's, aligned with what we're trying to do, all that, and then hand off the like product execution or whatever the corporation is trying to do to other leaders. I'm really curious when they get very good at that. But yeah, that's a really cool one.
Yeah. So there's a benchmark that I forgot who made this benchmark, but all the current LLMs fail it. It's called the vending bench. So the idea is that an LLM is able to just operate a virtual
The vending machine. Yeah.
Just being able to like stock the products, look at their, how many when they're running low, restock them, then set prices. Then as people come by, being able to like order more. The LLM has to set prices that are ideally above the cost of the product, and if it like messes that up, then it like will go bankrupt. And the benchmark just measures how profitable the LLM runs the business and for how long it can do this. And all of them kind of break down eventually, like the context just gets whack and they start making mistakes and they fail. But I think once we figure out the loop to be able to do that, I think that's when you can start doing some pretty meaningful things. This might just go in line. There's this neat graph around the length of the tasks that LLMs tend to pass, and that
love this.
That graph has been going up over time.
Yeah.
We're kind of around like a few hours now, and I think like soon enough we'll be in like the days and weeks setting of like sort of like equivalent human time. And so I think like that'll be like a later next year, we might be able to see some like pretty compelling things. If we can get like vending bench to pass, that will probably allow a whole range of knowledge good businesses to be made just purely from LLMs.
We should look real quick, but I thought the recent class of models were all just operating vending bench, but I could be wrong.
No, I think they're still not passing. Let's see.
They're breaking down.
We are, however, apparently a little bit ahead of schedule on that length of task trajectory. It's actually like they're approaching sort of days to weeks faster than initially anticipated, but it's tracking pretty well.
All right, I have a fun game to play because unless Carson, you have any like things that you really want to touch on, but I have a fun game. Well,
we had a whole list of things we wanted to touch on, but I don't.
Yeah, but I wanted to touch on a bunch of things that I know are important to Juan.
Oh, okay. Yeah,
we have them here.
Yeah.
All right, so I wrote some one-liners here. So you have to answer these in one line and give your probability. Name the scale that you want to put probabilities in. We can do whatever.
Give us an example.
Sure. What's the biggest ROI way to get funding to what truly matters, like human health and longevity?
Clarifying question: what do we mean by ROI in terms of return ROI, impact ROI, or sustainable financial ROI, such that you can cause more impact?
I know. Actually, that's really clever that you said that. I know. Actually, you've talked. So
what I would say, like maybe the one-liner is, you have to, whatever impact you're trying to cause, you have to think of some strong, sustainable, and high growth oriented way of doing it, so you can do it at greater scale. And today in 2025, and for the last 150 to 250 years, the best way to do that is by a profitable corporation with a very large cash flow. And so this is why things like Tesla were able to switch over from gas cars to electric cars and like cause a transition in the entire world. And so that is just a very like a dominant form of impact today. Now, in terms of how you cause specific impact, and ideally you're kind of measuring yourself against everything else that's going on, and you want to try and do way better than the rest of the environment. I think what you want to do there is like fund things out of the mean in the mainstream thinking. So go out of distribution to find things that are very contrarian and right, and you have to like figure out like what's going to be contrarian and right, and fund things that are just unlikely to be funded by many other groups. You mentioned longevity. This is kind of like why I ended up funding a bunch of things in longevity. It's not because I prioritized it more than other fields. It's just because other fields are very well funded. Longevity was like tragically underfunded, and like a small amount of money there actually catalyzed an enormous amount of impact. And I think that there's like, even within a field, you can find, ways of funding certain things that way. Lots of fields just get stuck in mainstream thinking. So this was a very long line. There's been semicolons all over the place, and I'm finishing it.
Okay. Yeah.
And dashes probably.
Yeah.
Yeah.
I am
maybe you can pick which way you want to answer this, back looking or forward looking. What has been or will be the biggest catalyst for solar adoption?
So the biggest catalyst, I think, just happened in the last year or two, which is the transition to becoming more profitable than many other forms of energy around the world, in many different locations in the world. And so we're now seeing this massive build out of solar all over the world, and it's amazing. I'm especially interested in large scale incentive structures for it, and this is where like I'm super excited about Glow specifically, like the crypto network, because that's applying the super powerful deep-end incentive model that Bitcoin pioneered and then Filecoin also built, to the problem of like how do you scale up and build as much solar as you possibly can. And so yeah, I think like those will be like interesting catalysts. I think battery tech will help a lot. The better battery tech gets, the more grids can just switch over to solar entirely. The build out in China is incredible. I used to be a lot more worried about climate change. I'm a lot less worried about it now, because I think the world has responded fairly well in terms of the technology build out that's happening, and I do think that the massive scale build out of renewables around the world, especially in places like China, is just awesome to see.
Yeah. Yeah, that's awesome. Let's see, I got some more here.
Well, you think it's interesting that you didn't mention anything about compute as a driver for increasing
For solar?
Yeah.
Yeah, because I think you can satisfy compute needs in large scale data centers with nuclear. And so if you can get nuclear built, then that's actually, I think, in the short term, a better choice. But I'm not as deep into the calculations here as many other people. And so I think large scale data centers probably immediately push on nuclear and then secondarily solar. I do think that solar just gives you this phenomenal independence. If you have a fab, right? Like if you if you have a fab, then you can just make massive scale amounts of solar cells, and you're like just not really limited by, you're basically turning sand into, energy plants. And like that's amazing. If you want to do a fission reactor or a fusion reactor, like you just need an enormous amount of materials and complicated tech that you have to build and whatnot. Like the big premise here is you're starting with a fab. Like building a fab in the first place is a very hard thing. But
you have time for 2 more questions? Okay. One. How to phrase this so you can put some probabilities on it. What's going to be the role of formal verification, especially with the most powerful models being built?
Yeah, great question. So I think formal verification is going to be much more widely used because now that we have LLMs, it drops the cost of writing it. Formal verification was hard when humans had to implement a lot of it. And so I think it's going to greatly increase in usage. I think the highest impact project that I can think of right now is an effort that actually booted up by the ARIA research R&D agency in the UK for using formal verification to safeguard the operation of AI systems. And so you use formal verification to prove some things about what models are running, what are they doing, what are the inputs given to them, what are the outputs, like the set of capabilities that the models have, and so on. And so you end up with a dramatically safer landscape in which to execute extremely powerful and capable models. And so I think that stands to be one of the highest impact applications of formal verification. Let's just remember, like, we are building extremely intelligent things that an agency is very easy to program. So, we're effectively building some like like agency and life are really easy to program. We've had digital life and digital agents since the beginning of computing almost, in the 50s, 60s. And we're now adding intelligence. So that was like the missing piece. And that means that we now will have super intelligent agents, super intelligent species of living things online. And we just need some kind of safeguarded way of ensuring, just broad alignment without going too deep into like all of that.
That whole area gets me a little bit uneasy still. I mean, I've just not gone many sessions with an LLM that they haven't tried to break the rules or do things like in coding. It happens all the time. I think the OpenAI solution for the mental health kind of issues is kind of telling, because I just don't know how many different problems you can solve by kind of like slowly patching them. And I'm sure that they're now, focused on getting that solved in the core. But basically, like, the way I read their solution is like there's kind of a router, and when it detects those kind of conversations that might become problematic, and the LLM might actually say the wrong thing to a person that it shouldn't be saying those things to, it will like move them towards a safer model or a safe. And I just don't know how well that's going to scale. So maybe it's temporary, but there's just so many ways that these things could go wrong. So it seems like our ability to patch it that way is going to be far outpaced by how sophisticated and how capable these things get.
I mean, I think that's where the formal verification becomes really useful, because then you can start to understand what is the total output space that we can, like, that this LLM could potentially explore given like prior inputs and things like that, so that we can like know ahead of time, like, oh, it's quite possible that this conversation could go in this direction, so we should like maybe not even let that conversation happen in the first place, or like we should change the input parameters so that we nudge it in a different direction. Or and then I guess this also incentive alignment, we should probably try to make it so that the LLM doesn't want to make, not push someone off of the deep end, that they really actually care about this person's well-being. And like, I think and that's why I always get uneasy about the guardrail stuff. Like, when you're coding, I put in guardrails for like our engineers and for our LLMs, because like that's the short and easy way to do it. Like, just, I told you don't do this, so just please don't do this. And when you do, I go, don't do that, and I nudge you back in the right direction. But like the best outcome is just like, you just,
how do the engineers respond to that?
Yeah, I mean,
Maybe this also goes away with just bigger, better model. Like, I don't know, because like maybe we're like getting, really high level coding from what are essentially like 3-year-olds, cognitively. I don't know.
Beyond 3-year-olds, but
they just don't notice when they skip the rules in coding. They don't notice like, oh, I know he was asking me to be helpful, but skipping the rules is not the right way. That is exactly what a 3-year-old does, by the way. They go like, I'm going to do it wrong to get to the outcome, not knowing that doing it wrong was the wrong way to do it. So
another analogy for how to think about it is think about the parameter space of the animals that are with a brain of similar size. And so I think like right now we're somewhere between a fly and a mouse ish. And so you have like, a super intelligent.
They're known to be good at writing code. So
like super intelligent. Like what's between a fly and a mouse? Like, I don't know, like a smaller mammal.
That's good.
I don't know. A small mouse. Like a tinier than usual mouse. And you have like this thing like now able to program and create symphonies and create movies and so on. And it's amazing. It's like savant at a bunch of stuff. But just give it like, 2, 4, 8 years and you'll have something the size of a human brain. And like then it'll be way more capable at like a wide swath of things that right now are just, quite hard.
Tell us what's the latest at Filecoin and what's coming next?
So with Filecoin, we're about to hit our 5th birthday. In fact, like tomorrow is the celebration of the 5th birthday of Filecoin, which is super awesome.
Filecoin. Pretty cool.
Yeah. And auspicious day for both of us, right? For all of us.
That is amazing.
With your launch.
Wow, that's so cool.
Yeah. That is
And
cool.
There's a whole range of things. The network is growing a ton in a bunch of different directions. It's very focused on achieving product market fit on a specific set of use cases, especially large scale data storage. And there's a whole range of things that people have been building. There's a thing called Filecoin on-chain cloud, which is a set of smart contracts that enable pretty granular services to be built, that then enable you to do all of the kind of like piping and plumbing that you would want in more sophisticated things, like a bot on GitHub that can back up your stuff and like have your credentials so that you can like just tag that bot and it like backs up and stores stuff, or like you GitHub push and immediately store like some agents in the network notice that push changed, back up all the stuff on Filecoin, ship the code, ship the update so that like update some name system record.
Uh-oh. You're back.
You're
back.
There we go. Yeah. So yeah, like all kinds of like really neat things that that are being built on Filecoin on-chain cloud, and like that's a major piece of software and product that the community is shipping.
That's awesome. And you personally, any like projects that you're really sinking your teeth into right now?
A bunch of things. So I've been like this kind of on-chain city of AI agents thing is something that I've been pushing on.
We lost him. Not allowed to talk about that.
We'll see if he pops back. I know we're going late too, so
yeah,
he's probably getting in trouble from people that want him in other meetings.
Mm-hmm. That was fun though. It's nice to catch up.
Oh, what a smart guy.
I did not know about the 5-year anniversary of Filecoin. That's pretty cool.
Yeah, me neither.
Hey, sorry about that. My network keeps falling apart for some reason.
On-chain city of agents. We heard it.
Great. Awesome. Let's just leave it at that.
Okay, cool. All right. We know you got to get back to your regularly scheduled day. So thank you so much. It was awesome seeing you and talking to you again. And really pleasure.
Good to see you guys.
Yeah, we'll see you again in person soon, hopefully.
Bye.